By the end of this video, you will understand why modern protection schemes need TPX, TPY, or TPZ CTs. The Transient Performance CTs. And how to choose the right CT class for your protection application. Let's start by understanding why we need Transient Performance CTs. In the past, protection CTs like 5P20, PX, or PS class were designed for steady-state, symmetrical short-circuit currents. That worked well when fault clearing times were long and system X/R ratios were low. But today's power systems are very different. Fault levels and X/R ratios have increased. This means the DC offset in fault current lasts much longer. We also use fast protection systems that trip within a few cycles. So, the CT must give an accurate secondary current even when DC flux is still present in the core. If the CT saturates during this transient period, the relay may misoperate or fail to trip. To address this issue, the IEC 61869 Part 2 standard defines three special CT classes: TPX, TPY, and TPZ. These CTs are designed to stay accurate under asymmetrical fault currents. Even IEEE standards recommend following these IEC definitions when specifying CTs for transient conditions. Now, let's quickly see how these CTs differ in construction. TPX CTs have no air gap in the magnetic core. That means they have high remanence, the core retains magnetism after a fault. TPY CTs have a small air gap in the core, which reduces remanence to below 10%. TPZ CTs have a larger air gap and very low or no remanence. Because of the large air gaps in the core, TPZ CTs cannot accurately reproduce the DC component of the short-circuit current. But TPY CTs can reproduce both the AC and DC components. Now that we understand why we need Transient Performance CTs and their construction differences, let's learn how to decide which one to use when. It depends on three key factors: remanence, a duty cycle, and system X/R ratio. If there is no need for low remanence, a TPX core is usually fine. If low remanence is required, usually less than 10%, then the CT must have air gaps. In that case, the choice is between TPY and TPZ because both are designed with air gaps. If the transient duty cycle has only a single energization, the close, open, or CFO duty cycle, a TPX core is fine. If the transient duty cycle is a double energization, such as in auto-reclosing operation, TPX CTs will saturate too fast during the second energization. So again, the choice is between TPY and TPZ. But how do we decide between TPY and TPZ? This is where the system X/R ratio comes in. If the system X/R ratio is not very high, choose TPY. If the system X/R ratio is high, choose TPZ. Let's summarize this part. If it's just a single energization and there's no need for low remanence, choose TPX. If your system has auto-reclosing or needs low remanence and the X/R ratio is not too high, go for TPY. But if the system has auto-reclosing or needs low remanence and the X/R ratio is high, then TPZ is the right choice. So far, we have seen why Transient Performance CTs are important, and how TPX, TPY, and TPZ differ in construction and application. In the next part of this series, we will go further and explore the two key design parameters that define CT transient performance: the rated symmetrical short-circuit current factor, KSSC, and the transient dimensioning factor, KTD. Thanks for watching.